All right, let's talk a little bit about molecular and ionic compounds. And so you should know by now that in chemical reactions, the nucleus, which contains the protons and neutrons, so we have protons and neutrons in our nucleus of each atom, and thus the identity of the element remains unchanged. So during a chemical reaction, if you do a chemical reaction with carbon, okay, it's still going to be carbon when it comes out. Okay, if you do a chemical reaction with oxygen, it's still going to be oxygen. It's not going to get transformed into another element. However, what does change is it says electrons participate in chemical reactions by being gained, lost, or shared. So electrons are what move around in chemical reactions, and as previously discussed, the gain or loss, this should say loss, not lose, the gain of loss of electrons results in the formation of ions. Okay, so we're going to spend a little time talking about ions. And when we talk about the main group metals, so main group elements, remember the main group elements are groups 1 and 2. So main group, okay, so main group are groups 1 and 2, and then 13 to 18, okay? But only the elements in those groups that are metals, it says they like to lose enough electrons to leave them with the same number of electrons as an atom of the preceding noble gas. So one of the conclusions we can draw from that is that any atom in group 1, okay, group 1 atoms are going to like to lose 1 electron and form a cation with a +1 charge, whereas metals in group 2, they like to lose 2 electrons and form a +2 charge. So an example would be something like sodium, okay? If you think about sodium, if you look at sodium on the periodic table, sodium has 11 electrons, but the noble gas that precedes it is argon, and argon has 10 electrons, right? So if sodium can lose 1 electron, it will become a sodium with a +1 charge, and then it's going to lose its electron. So I'm just going to balance that out. And again, the reason why this happens is because the sodium ion, okay, sodium +1 ion, has 10 electrons just like argon. Or neon, sorry. Now, if we take a look at an example like, let's pick magnesium, okay? So magnesium is a group 2 metal, and it likes to lose 2 electrons. So what would that look like? Well, if it loses 2 electrons, it's going to have a +2 charge, and it's going to lose 2 electrons. And again, why would this happen? It's because when magnesium loses 2 electrons, it's going to have 10 electrons, which is the same number of electrons as neon. So again, it's kind of like these metals have an identity crisis, and they want to be like a what? They want to be like a noble gas. So it says commonly nonmetals, things like fluorine, oxygen, nitrogen, phosphorus, sulfur, these like to gain enough electrons, again, to to give them the same number of electrons as an atom of the next noble gas. So notice when we're talking about noble gases, okay, and wanting to be like a noble gas, for the main group metals, you looked at the preceding noble gas, but for nonmetals, you look at the next noble gas, okay? So we see this with elements in group 17, things like fluorine, chlorine, bromine, iodine, and then we also see this with elements in group 16, like sulfur and oxygen, okay? So let's take a look at an example. Let's say we have fluorine, okay? Well, fluorine has a total of 9 electrons, okay? But if it gains 1 electron, it's going to become what we call a fluoride ion. It has a -1 charge, and now it has 10 electrons like neon, right? Okay, let's say we take a look at something like oxygen, okay? Well, if oxygen, which has 8 electrons, if it gains 2 electrons, it's going to have the same number of electrons as neon, okay, and then it's going to have a 2- charge. So again, fluorine is in group 17, likes to have a -1 charge, and oxygen is in group 16, likes to have a -2 charge. All right, so let's take a look at a couple more examples, okay? And this is just rehashing the same thing I did on the previous slide. If we take a look at calcium, it's element number 20 on the periodic table. When it's neutral, it has 20 protons and 20 electrons. Okay, well, if we look at a periodic table, you see that calcium is a metal. It's a main group metal. If you look at the noble gas that precedes it, comes before it. Okay, so the element that comes before calcium is potassium, element number 19. And then if you look at the element that comes before potassium, it's element number 18, which is argon, okay? So in order for calcium to be like argon, and again, argon has 18 electrons, and calcium has 20 electrons. Well, it's pretty straightforward math. How many electrons does calcium have to lose? And so calcium is going to lose 2 electrons, so it becomes a calcium 2 plus ion, and I'll just balance that out with its 2 electrons, okay? Now if we look at bromine, bromine's in group 17. Bromine is what we call a halogen, and you see the noble gas that follows bromine is krypton. Krypton has 36 electrons, and bromine has 35. So if bromine gains, not beryllium, if bromine gains 1 electron, it becomes what we call a bromide ion. And now this is going to have 36 electrons, right? The bromine had 35 electrons, but now it's got 36. And when you have an ion that has the same number of electrons as another element or another ion, we say it's isoelectronic. And so we would say that the calcium 2 plus ion is isoelectronic with argon. We would say that the bromide, or the bromine minus 1 ion, is isoelectronic with krypton. So that's a word you need to know, is isoelectronic. Okay, same number of electrons. Now, I gave this as a handout the other day, and I said you must memorize these charges. And so any metals, okay, in group 1, and we even include hydrogen, even though hydrogen isn't a metal, okay, anything in group 1 is going to have a +1 charge. So that's group 1, maybe I'll say group 1. Okay, everything in group 1 likes to form a +1 charge. Everything in group 2, like beryllium, magnesium, calcium, they like to form a +2 charge. Now, why would this be? Because any elements in the first group, right, if they lose 1 electron, they go back, right, and they end up having the same number of electrons as a noble gas. Now, hydrogen doesn't work exactly that way, but we'll address that more later on. Whereas if you look at all the metals here, right, beryllium, magnesium, calcium, strontium, etc., okay, all they have to lose is 1, 2 electrons, and then they become isoelectronic, okay, or they have the same number of electrons as the noble gas that precedes them, okay? Now, with aluminum and gallium, I guess you just kind of have to memorize these ones, okay? These are in group 13. They both like to form a +3 charge, right? Aluminum, if it loses 1, 2, 3, it's going to have 10 electrons, okay? And so the same thing would apply with gallium. If it loses 3 electrons, it's going to have, if it loses 3 valence electrons, it's going to have the same valence shell as argon. And we'll talk more about that later on. What else? For the nonmetals, so for things like fluorine, chlorine, bromine, and iodine, okay, these are what we call the halogens here. Again, you can see it's not a long trip, right? They just gain 1 electron, all of them, and then they're going to be isoelectronic with a noble gas. Whereas oxygen and sulfur and selenium, they have to gain 2 electrons, so you see them gaining 2 electrons. And then nitrogen and phosphorus, they're going to gain 3 electrons, right? Just try one more time. Phosphorus, why does it like to form a 3 minus ion? It's because it's going to gain 1, 2, 3 electrons to be isoelectronic with argon. Now, there's 3 more of these, okay? Normally the transition metals, okay, they have variable charges, but these 3 are an exception, okay? And these ones, you really have to just memorize them. You can kind of see the pattern for this one, this one, this one, this one, this one, this one, and the noble gases, which don't want to gain or lose electrons. But these 3 here are transition metals, and they only form 1 charge. So silver is always +1, zinc is always +2, and cadmium is always +2. There's no exception to that. So again, I know I erased it a few seconds ago, but you must memorize. You must memorize these, you know. And the more you use it, the more you're going to become accustomed to it, and you're going to start to remember that, you know, calcium is always 2 plus, potassium is always +1, sulfur is always 2 minus, etc., etc. So a polyatomic ion, you can see I scribbled one on here. A polyatomic ion is an ion that we have, all the ions that we have discussed this far are called monatomic ions. That is, they're ions formed from only 1 atom. And so monatomic, that would mean things like Cl minus ion, right? F minus ion, Ca2 plus. Okay, I can make a plus sign better than that, right? Sodium plus, right? Potassium plus, O2 minus, Br minus, right? S2 minus, P3 minus, so on and so forth. these all only involve one atom, right? A chlorine, a fluorine, a calcium, a sodium, etc., etc. But polyatomic ions are actually electrically charged molecules. So we have a cluster or a group of atoms bound together, and then they end up with an overall charge. And the one that I scribbled up here is what we call the carbonate ion. So CO3, 2 minus, this is what we call a carbonate. Okay, a carbonate, like that. And if you have, for example, if you have SO4, 2 minus, we call that a sulfate. So a sulfate. And really, you guys, I don't have anything else to tell you other than to say that the only way you can learn the polyatomic ions is by memorizing. Okay, they have to be committed to memory. And if you remember, I gave you a handout about that. Now, we can break the polyatomic ions down into another subclass, and that is what we call the oxyanions. And so you see that I've drawn 2 oxyanions already because oxyanions are just polyatomic ions that contain one or more oxygen atoms. So if I take these guys and move them down here, it's totally appropriate because they're polyatomic ions and they both contain oxygen. Now, polyatomic ions that do not contain oxygen would be something like NH4 plus. Okay, this is called the ammonium ion. Ammonium. Okay, like that. That would be an example of a polyatomic ion that doesn't have oxygen in it. Anyhow, so you saw I just wrote down the ammonium ion, and you need to memorize all of these polyatomic ions. So you need to know the NH4 plus. Okay, NH4 plus is the ammonium ion. H3O plus is the hydronium ion. If we have O2 with a -2 charge, that's called a peroxide. You'll see that in something like H2O2, which is hydrogen peroxide, and we'll look at that later. If you have an OH minus, that's hydroxide. If you have CH3COOH, now notice they're showing you it's bound together this way. You have a carbon that has 3 hydrogens bound together. Then you have a carbon that has a double bond to oxygen. And then you have a single bond to oxygen like this, and it has a negative charge like that. So that's what an acetate ion is. Sometimes you'll see it written like C2H3O2 minus like that, and that's okay. But normally, Mr. Dion likes to draw it this way. The next one is the carbonate ion, CO3 2 minus. We covered this one already. If you add a hydrogen to it, it only has a -1 charge, and we call that a bicarbonate. Sometimes we also call this a hydrogen carbonate. Okay, bicarbonate is more common, but to call this hydrogen carbonate is acceptable too. The next one is a dihydrogen phosphate. This is a long one, H2PO4 -1. The next one we have perchlorate, chlorate, chlorite, and hypochlorite. Okay, so there's a pattern here. Okay, if you can memorize the chlorate, which is ClO3 minus, okay, whenever you go from 8 to ite, you always lose 1 oxygen. So we go from ClO3 -1 to ClO2 -1, okay? And then if you take the ite and you go to the hypoite, so hypochlorite, then you lose another oxygen. So you go from ClO2 -1 to ClO -1. And you probably picked up on the trend here that if you go from 8 to per something 8, like perchlorate, then you add an oxygen. So again, as long as you know the 8, you can figure out the ite, the hypoite, and the per 8. Okay, you can kind of figure all those out. And so this same thing would apply to something like bromine. Okay, if we had BrO3 -1, that would be bromate. If we had BrO4 -1, that would be perbromate. If we had BrO2 minus, that would be bromite. And if we had BrO minus, that would be hypobromite. Okay, so again, we're going to get some more practice on that. All right, going back to our 8s and ites. Okay, if you can remember, nitrate is NO3 -1. Well, if you lose 1 oxygen, you have NO2 -1, and that's a nitrite. So nitrate and nitrite. Next one, I'll just skip over the hydrogen sulfate. If you can memorize sulfate, SO4 2 minus, if you lose an oxygen, you get a sulfite. So sulfate and sulfite. If you add a hydrogen to a sulfate, you end up with a hydrogen sulfate, HSO4 minus. Hydrogen sulfate makes sense. You take the sulfite, you add a hydrogen, it loses 1 negative charge, so HSO3. A phosphate is PO4 3 minus. you'll notice that the phosphate is the only one of these polyatomic ions that has a 3 minus charge. Again, the phosphate is the only one on the whole screen, okay? Then if you add a hydrogen, you get a hydrogen phosphate, and then if you add 2 hydrogens, you get the dihydrogen phosphate that we saw over here. Chromate and dichromate, so chromate is CrO4 2 minus, dichromate is Cr2O7 2 minus. Need to memorize both of these, of course. Permanganate is MnO4 minus 1, cyanide is Cn minus 1, and then last we have azide, which is N3 minus. Now, you might think, how am I going to memorize this? Well, you could just maybe sit down in a comfy chair or lay on the sofa and just sit there and try to memorize them. And that might work to some degree, but the best thing you could do is to try it, okay? Is to start trying to name compounds that contain these polyatomic ions. Now, every once in a while, a student will ask me, well, how am I going to, if I see a compound like, Na2SO3, how am I going to know that this is sodium sulfite and not disodium sulfur or some weird name that wouldn't be realistic, okay? And the answer is, the only way that you're going to know that this is a sulfate, oops, where's my pen? The only way you're going to know this is a sulfate is if you've committed it to memory. And so the polyatomic ions are just like learning a language. They have to be committed to memory. All right, so now that we've got that down, it says here when a non-metal forms 2 oxyanions, okay, I already went over this rule with you, okay, if you have an 8, like a sulfate, which is SO4 2 minus, okay, so this is sulfate, okay, and this is just repeating what I went over with you on the previous slide. If you lose an oxygen, so you make SO3 2 minus, then it becomes sulfite, okay, and we saw the same thing with nitrate. If you have nitrate, which is NO3 2 minus, so nitrate, like this. If you lose an oxygen, NO2 minus 1, it becomes nitrite, okay? So that's kind of a handy rule. When a nonmetal forms more than 2 oxyanions, prefixes are used in addition to adenite. So I told you that if you could memorize the chlorate, okay, or let's try it with iodine, okay? If we have IO3 minus, okay, this would be called iodate, okay? And if we lose an oxygen, IO2 minus, you'd call that iodite, okay? But then it says if you lose even more oxygen, so if you just have IO minus, then it would be hypoiodite. Hypoiodite. Sorry, guys, it's late at night here and I'm tired. Anyhow, and if you have IO4 minus 1, then that would be periodate, okay? Something like that, okay? And I showed you those with the chlorite, perchlorate, and hypochlorite, and I showed you with the bromine as well, okay? This is a periodic pattern of some 8 ions. So you see the ones in red are the ones that are most common, but all of these are 8s. So BO3 3 minus, that's a borate, carbonate, nitrate, phosphate, sulfate, chlorate. You have the bromate and the iodate. Okay, anyhow, if you want to spend time memorizing these, it could be handy. I just put this in the slides a few years ago in case somebody finds this useful. But for me, I remember learning these, and this is kind of how I did it. As I just started memorizing them, and I started naming compounds, made plenty of mistakes, but eventually I had them all down pat after a while. All right, so let's talk about the types of chemical bonds that we can form. And there's 2 main types of chemical bonds that we're interested in. One is what's called an ionic bond. The other one is what we call a covalent bond. And the difference between the two is going to be covered here. So when electrons are transferred, ions form and an ionic bond results. Okay, ionic bonds are electrostatic forces. So let's say you took a sodium ion with a +1 charge, so a sodium cation, and you put it in the presence of a chlorine -1 ion. Okay, that's what we call a chloride. Well, you guys know that opposite charges are going to attract, okay? So we have ions that are formed, they come together, and we're going to make sodium chloride, which is table salt, like that, okay? So again, we have a positive and a negative, they're attracted and they come together, whereas it says when electrons are shared in molecules form, then you get a covalent bond. And an example of that we looked at was when you have 2 hydrogen atoms like this, they both have 1 electron, they're going to come together and they're going to form a bond and they're going to share those electrons. So now we have a hydrogen molecule. So there's two electrons shared in this bond. Now, if you're looking at the first example, the sodium and the Cl- ion, and if you're like, well, you said transferred, you're not showing any electrons being transferred here. But let's think about that, okay? What had to happen to make a sodium +1 and a chlorine -1, okay? Well, we know that the sodium has 11 electrons, and it likes to lose an electron. So if it loses an electron, it can become sodium +1. And we know furthermore that chlorine likes to gain electrons to become Cl-, okay? So we see that the sodium lost its electron and the chlorine gained an electron. So who gave the chlorine the electron? The answer is the sodium, okay? So the sodium got the chlorine got its electron from the sodium. We created two ions, and then they're attracted to each other. So compounds are classified as ionic or molecular. If it's ionic, it's when we have two ions coming together. And if it's molecular, that's when you form covalent bonds, okay? So when you talk about molecules, like a carbon dioxide molecule or a glucose molecule, those are held together by covalent bonds. Whereas if you're talking about something that's ionic, like table salt, sodium chloride, or lithium bromide, or ammonium carbonate, or something like that, those are held together with ionic bonds, okay, which is an electrostatic force. So, like I said, metals readily lose electrons and they form cations, right? We said that something like sodium, okay, sodium likes to lose an electron. So when it loses an electron, it forms a +1 ion, and we call that a cation. So +1 charge, or positive charge, I should say, that would be a cation. Whereas nonmetals, let's pick something like bromine, okay? Bromine likes to gain an electron, right? It's a nonmetal, and then it can become, not Be, Br-, okay? And so when we have a negative charge, okay, we call that an anion. So when a metal and a nonmetal react, there's a transfer of electrons, just like I told you. When sodium and chlorine react, the sodium loses an electron, the chlorine gains an electron, we form a cation and an anion, and they're attracted to each other. And so how do you know that you have an ionic compound? Like, what's a giveaway that you've got an ionic compound? And the answer is shown right here in the slides, okay? If you form a compound that comes from a metal and a non-metal, okay? And this is a great way to remember. Ionic compounds come from a metal and a non-metal, okay? Think about table salt, sodium chloride, right? Sodium chloride, right? Sodium is a metal, whereas chloride is a non-metal, okay? You can find that out by looking at the periodic table. So a compound that contains ions is held together by ionic bonds. We call that an ionic compound. And when you're talking about ionic compounds, they're usually going to have really high melting and boiling points, okay? They're not going to be conductive in their solid form. You can melt them, and they will become an electrolytic. And anyhow, we'll talk about that more later. So again, if you take sodium chloride, okay? So just think about it. When it says high melting points, okay? I'm sure that most of the people who are listening to this video, if you put sugar, okay, just table sugar in a frying pan, can you melt it? The answer is yes, with relative ease, right? You can make a caramel sauce or something like that, right? Because sugar is a covalent compound. However, if you were to put, and don't do this, okay? If you were to put some sodium chloride, okay, which is a solid, table salt, and you were to heat that up, okay, is it really going to melt? Are you going to make sodium chloride liquid? Probably not, okay? It takes extreme heat. I mean, you would just make a mess if you in your kitchen if you start trying to melt sodium chloride. But it can be melted at extremely high temperatures, and when it does, it actually conducts electricity. So you could say here, the sodium chloride solid will not conduct electricity, but when you melt it, it does conduct electricity. Anyhow, don't try that at home, but we'll talk more about electrolytes later on in the class. Now, how do we predict a formula for an ionic compound? Because compounds are going to be electrically neutral overall. If you think about table salt, I'm sure you've all had some today. You didn't get a shock from it, so it tells you it's neutral. And so the formula of an ionic compound must have a ratio of ions such that you have an equal amount of positive and negative charges, right? They have to cancel each other out. And you can see that the example that I've brought up, I think, many times already in this video, if you take sodium plus 1 and you combine it with chloride minus 1, right, what do you get? You get table salt in a 1-to-1 ratio. Why? Because the plus 1 of the sodium is balanced out by the negative 1 of the chlorine. But we're not always going to be looking at ions that have plus 1 and negative 1 charges. What if you wanted to make a compound between aluminum and oxygen? Okay, well, plus 3 and negative 2 don't balance each other out, right? Plus 3 plus negative 2 gives you a positive 1, so that's not neutral. But if you take your aluminum and you multiply it by 2, and if you take your oxygen and you multiply it by 3, then what would you get? Okay, so let's think about that. We'd have Al 3 plus and an Al 3 plus, right? Overall, this is going to make plus 6. If we had 3 oxygens, so O2 or O2 minuses, I should say, O2 minus, O2 minus, O2 minus, 3 of them, right? That's going to make negative 6, right? And that's going to these are going to cancel each other out. And so the formula is going to be what? What we see here in the slide, Al2O3, like that. Now, there is another trick that students will use sometimes. I would just say, kind of proceed with caution. And that is this. If you take your aluminum 3 plus, not very neat, but anyhow, in your O2 minus like this, you can kind of crisscross the O and the 2 like that, and then you can say, okay, well, I need Al2 and I need O3, okay? Either way works, but I prefer to do mental math and just kind of quickly figure out how many of each ion should I have in order to cancel out the charges. So let's see if we can predict the formulas for these of the ionic compound that result from the following combinations of a metal and a non-metal. So notice we're talking about metals, okay? Potassium, calcium, sodium, barium, those are all metals, all right? And then iodine, nitrogen, oxygen, and bromine, those are all non-metals. Well, potassium is element number 19. It likes to lose 1 electron to become isoelectronic with argon. And so we're going to form a K plus 1 ion, and iodine is right next door to xenon. It just has to gain 1 electron to become isoelectronic with it. The ratio is the charges are positive 1 and negative 1. So they're going to come together in a 1-to-1 ratio. And so we're going to end up making Ki, okay? We call this potassium iodide. The next one, calcium likes to form a plus 2 charge, right? It loses 2 electrons, and it's going to have 18 electrons, which would mean isoelectronic with argon. Nitrogen likes to gain 3 electrons, because if it does, it becomes isoelectronic with neon. And so you know that if we have if you have 3 calciums and 2 nitrogens, so Ca3 and 2 like that, right? The 3 calciums are going to give you plus 6. And, did I make a mistake here? Sorry, I should have put N. I'm not going to go back and edit the video at this point, but anyhow, it's N3 minus, sorry. Again, it's it's late to me. I got little kids, so anyhow, I'm tired. So anyhow, Ca3N2. And again, I don't want to do this for every single one, but if you have 3 calciums, right, if you added that up, that would give you plus 6. If you had 2 we call this a nitride, this would give you negative 6, right? And they would balance each other out, so Ca3N2. If you're wondering, could you do that crisscross thing that you showed me, Mr. Dion? Would that work? The answer is yes. So you cross the 3 and the 2, and you get Ca3N2. Either way works. Let's go a little faster for the next one. We have a sodium, which likes to be plus 1. We have oxygen, which likes to be 2 minus. Again, if you're struggling with this, you could always go back here. Let's find it. All the charges of everything that we're looking at are here, right? The oxygen is 2 minus, right? The barium is 2 plus, etc., etc. So let's go back to the problem. So we have our sodium, which is plus 1, oxygen, which is negative 2. So we're going to need twice as many sodium, so Na2O, we call that sodium oxide. And the last one, we've got barium. Barium likes to adopt a 2 plus charge, it's in group 2. Bromine likes to adopt a negative 1 charge, it's in group 17. So we're going to need twice as many bromine, so we have B8Br2, like that. And again, we haven't learned how to name these compounds yet, but you can clearly see that they are all ionic. Why? Because they're comprised of what? A metal and a non-metal. So there you go, a little bit of practice on putting formulas together. So ionic compounds with polyatomic ions. So now we're turning up the heat because many ionic compounds contain polyatomic ions as the cation or the anion or both. Okay, so let's say you were going to make a compound out of sodium, which is +1, and carbonate, which is 2-. Well, you know you need 2 sodiums to cancel out the 2-, and so we would have Na2CO3. But again, the only way you can master this is if you know that this is a carbonate ion, right? You've got to recognize them, and then you can see that I treated it as a discrete unit, okay? I didn't start messing around with the carbons and the oxygens. I took the whole CO3 portion, the CO3 2- portion, and I treated it unto its own. Now, if you have a polyatomic ion that has to be repeated, and so in this compound, it only shows up once, but if your polyatomic ion, if you need it to repeat 2 or 3 times in order to get the charges to cancel, in that case, we use parentheses like this, okay? So let's say you wanted to make an ionic compound out of calcium, which is a metal, and phosphate, which is a polyatomic ion. It's made out of phosphorus and oxygen. They're both nonmetals, so they're going to form an ionic compound. Well, I need 3 calciums and I need 2 phosphates. And so the way I denote that is I put CO3 parentheses, open parentheses, PO4, close parentheses, and then I put this subscript 2 here to show me I actually have 2 PO4 3- ions to cancel out my 3 calcium. So hopefully that makes some sense to everybody. So with that in mind, moving on to molecular compounds. Molecular compounds are covalent compounds where the electrons are shared. They exist as discrete molecules. So things like water, okay, carbon dioxide, right, glucose, C6H12O6, okay. The list goes on and on and on. Those, as you can see, are usually formed by nonmetals, right? Carbon isn't a metal, oxygen isn't a metal, hydrogen isn't a metal, okay? It's on the left-hand side of the periodic table, but it's a gas, it's not a metal. It's a bit of an exception. So, often exist as gases, low-boiling liquids, and low-melting solids. And like we said, if you take, CO2, that's a gas at room temperature, water is a liquid, and glucose is a solid, but it's very easily melted at room temperature. So, with that in mind, I'm going to pause here, and then we're going to kick it off with chemical nomenclature.